Alright, 83 says find the solution to the systems below. Y equals 3x minus 16 and y equals negative 2x plus 9. So the thing that we should catch here is that we have the y equals and the y equals. If we have both of our equations as y equals, we go to our calculator. I'm basically going to type them in. So we have 3x minus 6 and we have negative 2x plus 9. Now I'm going to go to my graph. I'm going to see if I can see them cross on my graph. And I do. I'm going to estimate that the point is 1, 2, 3, looks like 3, 3-ish, maybe, just based off my graph. Let me just double check. So we go second graph. And I want to look at the point 3, 3, see if that's where they cross. So indeed, the point 3, 3. Again, I look at where y1 and y2 is the same. In this case, the 3 matches with 3. And so the point, and it's kind of confusing with all the 3's, but my point is basically just 3, 3. And that's it. That's my solution. Right, if I look at my equation, so if I'm looking at my graph, again, let me just darken my axes. That's x, this is my y. So remember that solution to the system is just basically where they cross, so I'm looking at that point right there. That's my solution. My solution looks like it would be, so again, I start at 0, 0, I do my x values first, so we go over 1, 2, 3. So my point is 3, and then I go up 1, 2, 3, so my other point is 3. So both of these answers are 3, 3. Alright, number 85, use substitution method to solve the system. So just really quickly, I did want to go over substitution, how to use substitution or how to solve using substitution. So first we look at y equals. So y equals negative x plus 6. That basically means that y and that negative x plus 6, those two are the exact same. So that's what I'm going to be subbing in. So my second equation is what I'm going to be subbing into. So we have 2x plus 3y equals 22. So anywhere where I see that y, instead I can plug in negative x plus 6. So this would actually be 2x minus 3. Instead of y, I'm going to put in negative x plus 6 equal to 22. Alright, from there I draw my line down my equal sign. Again, I have to distribute first. I have to get rid of my parentheses first. So 2x just comes down. I'm not going to mess with that for now. And then I distribute my negative 3. So negative 3 times negative x is going to give me a positive 3x. Negative times a negative gives me a positive. And then negative 3, again, this thing, negative 3 times 6, which is going to give me negative 18, equal to 22. Alright, again, and that's why, again, we draw our line down our equal sign so that I'm not making the mistake of trying to move the 2x over and then the 3x over. Since I have a 3x and I have a 2x and they're on the same side of that line, I can just simply add them together. So 2 plus 3 is going to give me 5x. So really I have 5x minus 18 equal to 22. And then I do plus 18. And I get 40. So I'm going to move my equation over here so that we can finish it off. 5x equals 40. And my last step is going to be to divide by 5. So we get that x is equal to 8. Alright, again, we're solving a system, so we need a point. So my x value is 8, and I'm looking for my y value. And the easiest way to find your y value is to plug it in to that equation that you substituted for, or from, I guess. So that equation would be, I'm going to go ahead and write it over here where I have space. So that equation would be the equation y equals negative x plus 6. Again, I know that my x value has to be 8 now, so we have y equal to negative 8 plus 6. And then I just simply add these two things together. Negative 8 plus 6 is going to give me that y is equal to negative 2. And so my y value is negative 2. Alright, we'll flip over to the back. We're almost done, or I'm almost done with the ones that I'll work, at least for today. So it says use the graph below to answer the following questions. How many roots does the parabola have? How many zeros does the quadratic have? Alright, so both A and B are actually asking you the exact same thing. So roots is the same thing as zeros, which is the same thing as x-intercepts. And again, zeros is the same thing as roots, which is the same thing as x-intercepts. So these are our vocabulary words, roots and zeros. And again, parabola is the same thing as a quadratic, and a quadratic is the same thing as a parabola. So they are simply asking us the exact same question they're asking us twice, which is how many x-intercepts do we have with our U-shape or with our parabola? How many times does it touch the x-axis? So there's my x-axis. There's my x-axis. There's my parabola. And those two never meet, right? They're off by that much, but they never meet. So this is going to be 0 or none. And this will be none. And that's it. Pretty easy. Alright, 89. 89, part A. It says, what is the vertex of y2? So we look at our table, and our table looks a little confusing. Our table looks a little confusing. What I want you guys to make sure that you take note of is that we have an x value up here, and then we have y1, y2, and y3. So every single time that you have a point, your point needs to be x and y. So it looks like since we only have one x, it has to be this column. And then depending on what equation we're talking about, it'll either be 1, 2, or 3. Alright, so first thing is vertex of y2. So first thing we want to do is we want to start doing our symmetric pairs. So I basically want to start looking at my y values, which ones can I start pairing up. So on my y2, I can start pairing up the 6 with the 6, the 9 with the 9, and the 14 with the 14. Right, I start pairing those up. The only one that doesn't have a pair is going to be the 5. And again, I'm only talking about my x and my y, so I want my point. So I don't need that y1. So really, my point is going to be the point 0, 5. Again, this 0, and this 5, right? Because I don't really need that y1 there. I just looking at y2. So I need an x and a y. So my x value is 0, my y value is 5. So my vertex is going to be 0, 5. Next, for B, it says, what is the axis of symmetry of y1? So once again, even though it doesn't tell me to, I need to find the vertex so that I can find my axis of symmetry. So I go to y1 this time. On y1, I want to find my vertex. So again, I start pairing them up. So symmetric pair with symmetric pair. So 1 with 1, 4 with 4, 9 with 9. It looks like, once again, my only value that doesn't have a pair is going to be the 0. And again, this time I'm talking about y1, so we have x and we have y. So 0, 0 is going to be my ordered pair, or my vertex. In this case, we're talking about axis of symmetry, so it's only my x value. So in this case, it's going to be x equals 0. Make sure that you write x equals and not just 0. And then finally, what point is symmetric to 1, 6 in y2? So we go back to y2, so I no longer need y1. And we're talking about the point 1, 6. So we're talking about this point. The 1 and the 6. What point is symmetric to it? So we basically just follow our line that we already drew. It looks like this and this. So the point -1, 6 would be our symmetric point. And then finally 90, it says describe how the graph y equals x squared plus 3 would be affected if it were changed to y equals x squared minus 5. Any time that it gives you something like this, you want to just simply go ahead and graph it on your calculator and look at the graph. So we have x squared plus 3, and come on, x squared, come on, minus 5. Alright, so there's my two equations. I hit graph. There's my first equation. There's my second equation. So remember that parabolas don't necessarily get bigger. They just simply get lower, especially if we're not changing our coefficient or our number in front of x squared. So if I'm not changing the thing in front of there, one might appear a little bit bigger, but that's just because we see a little bit more of it. Really what I see is that one of them we have our y-intercept at 3. For the other one we have our y-intercept at -5. So really all that's happening is I'm taking that parabola and I'm pulling it down to that point right there. So it looks like we're going down 1, 2, 3. Come on. Come on. Alright, it looks like going down 1, 2, 3, 4, 5, 6, 7, 8. So this is just simply going to be shift down 8. And here's how you would actually do this algebraically. Algebraically, what you would do is you would do y equals x squared plus 3. If I wanted to shift this graph down 8 units, I would simply just say minus 8 to my equation. Again, my y doesn't change, my x squared doesn't change, and then I just do 3 minus 8, which would give me -5. Which is how we go from this graph to this graph, is we go down 8 units. So that minus 8 stands for down 8 units. Alright guys, this is as much as I'm going to do today. Like I said, I might, if I have time, go through the rest of these and maybe go back through and get the ones that I skipped. But at this point, I think you guys should have most of your review done, if not all of it. But just for those stragglers, I think maybe tomorrow I'll really try my best to get the rest of these done. Alright guys, have a good day.